My name is Mark Langenhan. I'm with Total Piping Solutions. We are a manufacturing operation located about 75 miles south of Buffalo, New York. And I've been asked to pre-record a presentation that I've done numerous times throughout North America. We've actually trained over 2,000 operators since last April, since this pandemic began, and in lieu of face-to-face training at a lot of trade events. So what we do is we manufacture pipe repair products, clamps, couplings, tapping sleeves, service saddles, encapsulation sleeves, you name it. We produce it. We ship about 98% of everything we ship in the, between day one and day five, of the order, depending on the size of the order and the type of the product. So, if you think repair products, give Total Piping Solutions a call when you get a chance. So, what we want to do today is really present some different options relative to making repairs and give you a kind of a preview into a slightly different way of making a repair, and we call it the smart repair option. So I'll be working back and forth between PowerPoint and a little bit of hands-on on this thing. So again, this presentation has been presented, to almost 2,000 operators for actually continuing credit hours for operator training, and provide some, I think, some helpful information relative to making an economical repair. So why we're here today, and of course, I think the big thing is how do we justify what we do and why we're in business. There's a lot of repairs that happen on a daily basis. If you look at really what's happening in the industry, you can go to the water main break clock online. It's put out by the Canadian AWWA. Looks like the national debt clock. The needle just keeps going round and round and round as breaks add up on a daily basis. 850 a day in North America, 310,000 a year. That's a lot of water main breaks. So when we look at the cost of water main breaks, that's a big number. It's in the billions. Average cost of repair is somewhere between $5,000 and $9,000. And why do we repair instead of replace? Pretty easy example here. And for what it's worth, all the numbers that I present have been obtained through working with AWWA, different utilities around the country. They've all been well hashed over and pretty well verified. So when we're going to replace a mile of line anywhere, whether it's in Maine or California, wherever, we're looking at about $1.5 million a mile, whether it's PVC or ductile or whatever. There's a lot of excavation. There's a lot of material cost. So $1.5 million a mile is a lot of money. If you look at the average cost of a repair at $7,200 a repair for a 6 or an 8-inch main, how many repairs can you make for $1.5 million? Almost 210 repairs. So that puts us into the pretty much the perpetual business of making repairs, because without a way to easily fund outright line replacements based on the number of miles of line that are in the market today, we're going to repair lines forever. So on that note, let's look at how we break down the cost of a repair. And I think that's pretty straightforward. We've got, backhoes, equipment costs, operator costs. That's about $5,000. That's the biggest chunk of change in making a repair. Labor is the second biggest, and that's pretty well substantiated across the board. Labor rates are pretty even across the country relative to, operators. Here's a number that's a surprising number, and this came out of any number of repairs. And to give you an example of the type of repair and where that number comes from, I was on a repair several months back, and as soon as I got there, the excavation was open. They were dewatering the site because there was a lot of groundwater rushing into the excavation. The pump broke, so the job shut down. The excavation filled up. They had to run back to the shop. They had to get a new pump. They brought the pump in, dewatered again, got back in, started cutting the pipe for the second time. boom, the blade breaks. No extra blades. Had to have a distributor from Hamburg run the blades into the job site. So that was another hour and a half. So, time lost on the job due to equipment malfunctions and things like that are things that you don't normally think about, but they do happen. So that's an intangible. Material cost, small component of the total cost of repair. So this is how we establish our $7,200 repair cost. And if we look at it, everything as a percentage of the cost of repair, the smallest proportion of the cost of any repair is the price of the repair product that we're using. So everything else is labor and time. And I always look at the cost of repair products. I guess maybe in the right way to look at them. When we're buying repair products and we buy low bid, we're not doing ourselves any favors, because when we buy low bid, we're getting inferior materials. We're not getting the premium performance that we expect. And typically we're not getting products made with the longest life that are possible out there either. So if you look at repair clamps, there's a lot of different kinds of repair clamps. So there's the fabricated clamps that are all welded fabricated. Those clamps only last 8 to 10 years typically. They're a low bid item. They're only good for like 60 or 75 pounds of working pressure. You can buy a repair clamp for, a little bit more, maybe 15, 20% more on the price of a repair clamp, get a repair clamp that's rated for 50 years of life, 200, 300 pounds of working pressure. So, a little bit isn't always the way to go on products, and something of worthy of consideration relative to the total cost of the job. So there's other components of every job that are involved, and that could be sampling, downtime, angry customers, boil notices. You name it. There's a lot of things that are involved with making a repair, and we want to make it safe, and safe for the worker that's doing the repair, safe for the public at the same time. So when we look at how to make line repairs, typically 2 to 12 inch, that's most of the pipe in the ground. There's 3 ways to make a repair. We can clamp around the pipe. That's probably the most prevalent used type of repair. We can do a cut-in repair where we cut it out, bring in 2 couplings or 2 MJ sleeves, piece of new pipe. That takes a little bit more time. And then we can encapsulate the leak. It could be a leaking joint. It could be a leaking coupling, old repair clamp. Any number of things can leak on the line. So before we start any repairs, what we want to look at are some of the things that are essential towards making a successful repair. So when we do that, we always clean the pipe. And every manufacturer says clean, descale, wash it down with some water. Make sure you have a good sealing surface for whatever you're putting on the pipe. Secondly, always measure the pipe diameter. And I'm going to go back and forth between these slides and a little hands-on here. And at this point, we've got an OD tape here. We supply those if anybody needs them. And essential to know how to use an OD tape, believe it or not. When we're using an OD tape, I had a guy not too long ago, and we'll just pull it up here. You see the little pull tab here? He pulled it around and he read to the end of the pull tab. Well, that pull tab is about 1/4 of an inch long. That ended up being a full inch difference in diameter on the pipe. He had the wrong repair product out on the job site because he didn't know how to use the repair OD tape. When you're using an OD tape, always measure to the beginning of the scale, not the pull tab. So, that's some basic training stuff that people need to know and be aware of. And I think it's essential to what we do with our jobs on a daily basis. So know how to use your tools and your products that you're using to make the repair. Always read product labeling. There's tons of good information on product labeling. Is it restrained? Is it non-restrained? Is it good for water, sewer, natural gas? What is the line content that the product is compatible with? And last and foremost is the torque on the product. Why do we want to talk about torque? Torque protects the pipe. Too much torque can crush the pipe. Over torque can crush the product or deform the product. And a proper torque sets the gasket at the optimum gasket setting for performance of the product at a working pressure that's satisfactory for the product itself. So one of the things that I look at is, all right, nuts, bolts, and washers. And perfect example, I won't say who in upstate New York did this, but they called us and they said, hey, the bolt's bent, the lug's bent on the repair clamp. And what we found out was that they failed to read the directions on the product. They were using an impact driver, and the impact driver had 3 settings on it, A, B, and C. Setting A was 75 foot-pounds, setting B was 150, setting C was 250 foot-pounds of torque. Supervisors said just set it up to, setting C, that's plenty of torque. Well, at 250 foot-pounds of torque setting, what happens to a bolt? Every material has got a yield point built into it. The yield on a bolt, and this is a standard Waterworks bolt. It's 304 stainless steel. It's coated with Xylan, which is a lubricant to prevent galling. The yield on that bolt is 150 foot-pounds. So what happens if you hit 150 foot-pounds and you exceed that? The bolt stretches, and then the bolt starts to bend. So every material has got a yield point, and too much torque will actually interfere with the performance of the product. So when we look at that, let's make sure that we're using our tools properly. So next thing we want to talk about is, repairs with repair clamps, the proper way to do them. One of the things that we do is we're going to fix a lot of different kinds of things with a repair clamp. It's under a reduced pressure, always under reduced pressure. Repair clamps are not designed or made to be installed under full working pressure. No product is. All seals work better under reduced pressure. And when I say pressure reduction on a repair clamp, what is that? Take it down to 10 or 15 pounds. Can't find a valve that works, and I've been on several jobs like that where we have an old system. We've got valves that haven't been exercised or used in years, and you can't shut the water off. So what do? Open a couple hydrants, drop the pressure down, bleed everything down, get it to an acceptable point where the flow is dropped, the pressure is dropped, and then the seal will work, in a pretty good fashion. So one of the reasons I'm talking about seal is if you look at a repair clamp, this is our quick cam repair clamp, real easy to use, high performance product. Every gasket on every repair clamp, whether it's our repair clamp or otherwise, we've got to show this, has got a tapered end on it. And that end, that tapered end can actually bend over and pinch off. And actually operating pressure will cause that to bend over and pinch off. So what happens if it bends over and pinches off? We have a problem. We have a leak path built into the gasket when that happens. So you want to make sure that everything stays in line. That won't happen. The pressure won't push that, taper over for a bend. That's got to be laid over and rotated and smoothed out on the pipe. So to get a successful seal on, any kind of a repair clamp, whether it's a quick cam made by Total Piping Solutions or whether it's, brand X, Y, or Z, make sure you always reduce the pressure. Other thing you want to do is lubricate the gasket on a repair clamp too. Lubrication allows all the little indentations and imperfections, the peening on the ductile pipe, everything to smoothly settle in and the gasket to seek the lowest point in a quick fashion. So lubrication is helpful in installing any clamp. In lieu of lubrication on a repair clamp, you can always use soapy water. So I got a bucket of tub lube back here. We like that product. It's an OD lube. There's poly water. There's all different kinds of lubes. This lube that we use is a little thicker. It doesn't really wash out under pressure very easily, and it is water soluble and NSF 61 certified and approved. So good for use on any kind of pipe repair. When you're doing a repair with a repair clamp, though, what are they good for? Splits, circumferential brakes, or circle brakes as we want to call them. Can a repair clamp be used like a coupling? Up to 1/4 inch pipe gap, you can join 2 ends of pipe together, but it is not a coupling and should never be used as such. And what does a coupling allow for? Coupling provides flexibility between the ends. A repair clamp is a stiffener. So if you take a joint, stiffen it, and no more than a quarter of an inch end gap from end to end with a repair clamp, because repair clamps rely on gasket surface area in contact with the pipe. And as soon as you start increasing the gap, you start limiting the amount of gasket in contact with the pipe, and the working pressure rating of the product itself drops. So never really to be used as a coupling, because it does stiffen the pipe. It'll send the brakes somewhere else if you stiffen it. So, you know, when using like that to join pipe in a pinch, you might be able to do it. Coupling is a better device. Repairing holes, splits, breaks, cracks, you name it, with a hole in a line no more than 3 or 4 inches. Anything bigger than that, the clamp, every repair clamp will lose its effectiveness as far as how it works in terms of working pressure rating. So repair clamps are great for making service renewals. If you've got an old service that's rusted out or broken out, no need to clamp over or you know, replace the previous tap point in the line. Buy a repair clamp with a pre-tap port in it, and the taps can be 1/2 inch through 2 or 3 inch CC or IP threaded. And you can just take a longer clamp, like a 15-inch long clamp, center it over the old tap point with the new port, and renew the service through the repair clamp. Typically, if you're going to do that, if the old tap was 3/4 inch, you're going to renew it with a 1 inch. So you're always going to upsize when you're doing a renewal through a repair clamp. Makes sense, and it's a real easy way to renew service. So you know, keep that in mind. Again, everything needs to be done under reduced pressure. When you think about making a repair on a leaking bell or some kind of leaking joint, would you ever use a repair clamp on that? No, never. Whether it's stainless, whether it's ductile lugs or whatever, as soon as you step the gasket, you lose working pressure rating. As soon as you interrupt the gasket path or the way it lays on the pipe, you're going to lower pressure rating. So it's not to be used for anything other than, you know, complete and total inline repairs. When we look at the standard repair in the industry, other than repair clamps, I call this the go-to repair, and that's your cut-in repair. And what we do is you know, basically what we're all doing is we're doing leak detection. We find the leak point, and then we have to make a determination of how we're going to make that repair. So repair clamp, cut-in repair, depending on the severity of the damage, or maybe encapsulation of that leak. So when we're looking at the traditional process of a cut-in repair, identify the leak point, shut the line down, cut it out, bring in 2 repair couplings or 2 MJ fittings, new piece of pipe. You're going to bring it and couple it all back together. So again, locate and identify the break. We do a shutdown, pipe clean, measure the pipe after we clean it to get the proper OD, select the product, remove the damaged section, and then you're going to disinfect as part of the reassembly process and replace with new pipe and 2 couplings. So it's a pretty big job. Takes somewhere between 2.5 and 3 hours for a 6 to 8 inch repair. Again, everything needs to be tightened to the proper torque. And of course, the bigger the diameter, the longer the time. So when you get up to a 12 or a 16, you might be into it for 3 or 4 hours on a repair like that. So those types of repairs are you know, very common in the industry, but they do require a lot of time and labor. We manufacture a coupling here. It's a 2-bolt coupling. We'll just show it to you real quick. It's called the TX3. It's got 12 to 14 mils of epoxy, and it's a three-layer coating system. We've got a zinc prime coat underneath. We split the end ring, compression end, split end. That split allows us to easily assemble them here in Olean without a hydraulic press, pushing the gasket on. Nice handle, higher working pressure than anything else out there. It's rated at 275. Gasketing, NBR and SF61 approved for 61 and 372, which means don't worry about lead in a gasket compound. A nice layered gasket system, inner layer, outer layer. The inner layer is good for IPS, ductile cast iron. The outer layer is good for AC pipe diameter. So the inner layer, if you remove it, as you can see, it just pops right back into the grooves. you can put it back in. So we don't really need to worry too much about ruining the product because we pulled the gasket out at the wrong point. It's not a flip out gasket. It's not a change out gasket. Everything is integrated. It's all fully replaceable. So I think it makes it very convenient, for use on cut-in type of repairs. So going back to, those types of repairs, the next thing we want to look at is repairs on other things. And you probably think, well, we've already covered those things. Well, if we look at the number of repairs that are done on the most predominant pipe sizes, 4 through 12 inch, that represents 85% of the repairs in the marketplace. What you don't realize, and again, this is a number that we've pulled out of AWWA, working with different utilities around the country, 20 to 25% of leakage occurs on existing lines, on old couplings, on joints, push-on joints, rolled gaskets, AC pipe collars, universal cast iron pipe joints that are leaking. There's a lot of things that leak underground that just don't involve pipe breakage or rust or corrosion, that type of thing. So that's a lot. That's 75,000 leaks a year on existing joints. So I think what we've got is something to take a look at that's worthy of consideration for repair of these types of joints that you see in this slide. AC pipe collars leak on a regular basis. You've got a ring joint in there with a gasket. As they age, they wear, or if you get any movement or deflection, if the pipe doesn't break, it's going to roll the gasket and you're going to get a leak. Universal cast iron pipe. See a lot of this on the east side of the state. And Yonkers is one area that I know that they've got a lot of universal cast iron pipe. And that's machined end to machined end. It's 2-eared pipe with through bolts pushing the ends together. Kind of interesting. It was gasketless pipe, and they relied on the 2 machined ends mating and enough pull there to prevent leakage. If you look at the old standards for universal cast and for AC pipe, after installation, there was an acceptable amount of leakage, and that is actually in the standards. And that leakage was expected to dissipate as the line calcified over a period of time. And that typically happened pretty fast. So next kind of joint that we see a lot of leakage on, and leakage on joints like bells and spigots, universal cast iron. These are your traditional shut it down, cut it out type of repairs. That's your go-to repair, with 2 couplings, piece of repair pipe. If you didn't have to shut it down and cut it out, why? If you shut it down, you're going to expose the idea of the line to contaminants. It's a longer repair to make. Lead joints, very common. There's 2 kinds of joints that are caulk joints, and we qualify those as caulk joints. And what we mean by a caulk joint is it's a joint. It's a bell and spigot joint. You've got some kind of a rope packing in it, and then the rope is retained in place with either lead or leadite. Now on the lead joint, which would be this joint here, that joint was originally packed with asbestos rope, and then the rope was retained in place by lead that was poured around the backside of the joint and then tapped into place with a hammer. And so those joints leak over time, especially if you get movement or deflection. The advantage of the lead is you can pack it back into the joint, you can tap it back into the joint, and sometimes stop the leak without having to do anything. So if you can't, or you get a cracker or split in a hub or a bell like that, then you got to think about doing something else on a joint like that. The other type is leadite. At the end of the 1930s, lead became in very short supply in North America because all the lead was being used for munitions for World War II. They came out with a powdered product called leadite. It was an early plastic. It was a black powder. You mixed it with water. You poured that into the lead mold to retain. And at that time, they weren't using asbestos rope. They were using jute that was impregnated with graphite. So they packed that jute in there. And I think even at that time, they recognized the dangers of asbestos, and that's why they went to jute. But and then that was retained in place with the leadite, which is that early on plastic. Problem with leadite is it cracks. It can't be packed into the joint. It's just a joint retaining type product. So, and we're at the end of the life of leadite at this point in most systems, and that's where we're seeing a lot of leakage. So, what else leaks on joints? Old couplings, push-on joints. You ever have a push-on joint, ductile, cast iron? Contractor overrolled the gasket, overbelled the pipe, you got a leak. So how do you handle that? Fusion joints, that's another thing. We're seeing more and more and more leakage on fusion joints. If you look at any kind of pipe generationally, every generation of products out there is the perfect pipe at the time. Even HDPE, current generation of pipe, is not the perfect pipe. We see all kinds of damage and leakage on HDPE on a regular basis too. So it doesn't corrode, but there's other issues with HDPE, and a lot of that is on fusion joints, whether it's a butt fusion or a fusion fitting of some kind. They do have issues. So one of the ways that we look at repairing a bell and spigot joint or any kind of a joint leak like that is with a bell joint harness. One of the problems with a bell joint harness is a lot of components, labor intensive, takes time to put on, and they're not permanent. And one of the things that most installers don't realize is if you look at the fine print, the directions in the box, all the manufacturers universally say the same thing: remove the lead, remove the leadite, remove the rope caulk, replace the rope caulk, and then use this to retain it in place. That's really what this is for. It's a gasket retention device with a gasket that's used to retain the packing in the joint. So is it permanent? No, it's not permanent. It's temporary, might last a couple of years. You might even have seen them last longer. The reason it's not or lacks permanence is when we look at the gasket in this area that we're pushing in, the gasket is not retained by anything, and it can flow away from the push point or the point of pressure on it. And it will eventually drop down in working pressure rating as it ages. So not permanent. So when we talk about encapsulation, and I've alluded to that a couple of times, why are we interested in joint encapsulation rather than cut in or other types of leak repairs? In 2014, AWWA issued the C651 2014 standard. It raised the bar in the industry as far as requirements for disinfection. And rather than read that standard, it's easily broken down into 3 different categories. Number 1 is a controlled repair without depressurization, and that's the use of a clamp or a coupling. We can do that under reduced pressure. We're going to just really repair the leak by covering the leak point under reduced pressure, whether we use an encapsulation sleeve or a clamp, and we're going to just flush, get a normal residual. We really don't need to test there. That's a quick, easy repair. The second kind of repair, and this is where this standard starts kicking in: semi-controlled open cut repair. What does that mean? We've got an excavation. We're going to do a cut-in repair. It's above the water table. We don't need to worry about groundwater contaminating the ID of the line. And so it's kind of controlled. And so we're going to use a couple of couplings, a couple of MJ fittings, that piece of repair pipe section. And then we're still going to have to disinfect the line with a 1% chlorine solution. And then we're going to flush to clear and do a quick biological sample. So that's a common repair. Here's the repair that we're most concerned about, and that's the uncontrolled open cut repair. And that was that repair that I talked about earlier, where we had the excavation, the pump broke down, the water table came in, the line, the internal components of the line got contaminated by groundwater because the cut had started, the pump broke, the line was open, we contaminated the line. So what do you do in that case? You're going to make your repair, you're going to disinfect, but you're going to treat it like a new line. It's got to be a hot dechlorination. So you're going to do that over a 16-hour period of time, like commissioning a brand new line, or we're going to do a super chlorination and flush over a 15-minute period of time. And even if you do all that, you still need to put out a boil notice. You need to have a biological sample, and working with like I know our friends over at New York State Rural Water, I've had some discussions with them. Most labs come back in 24 to 48 hours. The target time is 24 hours. Just because of the backup in a lot of labs, typically it's a day and a half to 2 days to get results back. So while you've got all that going on, what do you have? You got mad customers, you've got shutdown, you've got people that can't use the water. So if we look at the two types of repairs, your cut-in repair, encapsulation repair. Let's evaluate both of those repairs. Cut-in repair, 2.5, 3 hours. Encapsulation repair, 20, 30 minutes. So you're going to eliminate the shutdown. You're going to eliminate the need to disinfect. You're going to have to lower the pressure a little bit to make that repair, but it's an under pressure repair, and it really speeds up the process, cuts a lot of time and a lot of labor. So they're competitive, no more than the cost of really 2 couplings and a piece of repair pipe. We've eliminated the end gland that needs to be tightened down. And years ago, I worked at a company called Dresser. Everybody knows the old Dresser coupling. We made a product called a Dresser bell pack. And this is what the bell pack used to look like. This is our design today. We call it the Ultra Sleeve. The bell pack had perimeter bolts all the way around. And then, like a lot of MJ sleeves that you guys are familiar with today, we have an end gland that we have to tighten down in order to squeeze the gasket on the pipe. We have figured out a way to do that without having to have that end gland in there. So by eliminating a whole bunch of bolts, in the case of a 6-inch, probably about 16 bolts on the end, we've actually enabled you to speed up the installation process on that with the gland. So we cut labor, we cut excavation time, and we've made these things wide range so that 1 6-inch covers everything, 1 4-inch, 1 8-inch, and then when you get into the 10s, the 12s, 16s, and 20s, it's a little different up there because there's a lot more range to compensate for in the pipe. But we believe that we've developed a cost-effective solution that can allow you to repair a fusion joint. Good example on fusion joints. Job in Connecticut not too long ago, there was a couple miles of HDPE pipe. It was all fused. They were 40-foot long sticks. And when they went to commission the line, they had about 20 fusion joints leak. And they were all butt fusions. Contractor was in a hurry or didn't know what he was doing. Water got in the fusion, little drops of water, you got bad fusion. There was dirt in some of the joints. So when they went to pressure test it for the commissioning, all these joints started failing. And so what did they do? They had to make a really consideration for how to make a repair on those joints. The utility said, shut it down, cut it out, and just replace the line, do it over again. And the contractor, of course, didn't want to do that. They said, well, we've got some options. And when we're doing a fusion joint repair, what can you do? Well, one of the things that happens on a fusion joint, interestingly, is that when you're doing a fusion, you're going to heat 2 ends together, you're going to jam them together under pressure, and then it's really plastic welding. So the 2 molten ends meet, they cool, but when that happens, you push up what we call a weld bead, just like welding metal, and that's a 1/4 inch bead that goes all the way around the pipe. The problem with repairing it, you can't really use a repair clamp, because when you look at a repair clamp is an inline device. As soon as we put an interruption in the pipe, the repair clamp is not going to work properly. You're going to get a reduced working pressure rating. So some of the folks at PPI said, hey, just shave off that weld bead and then use a repair clamp over that. Well, 2 things. We still got the contamination in the joint. The repair clamp is going to squeeze that product down, and it's going to neck out, and then it's going to eventually leak in the future, and the joint's derated. So when you look at it like that, probably not the best way to do it. You can encapsulate that, and with encapsulation, it's kind of a neat, easy way to do it. And then the encapsulation of that joint responds to really the working pressure of the line and works back and forth with the pipe itself. So, cost-effective solution, any kind of joint, ductile, cast iron, PVC, AC, large splits or breaks. You can use these like repair clamps. You can use them like couplings. You can use them to go over old couplings, old repair clamps. They can be used to fill pipe gaps, which you can't do with a lot of products. They'll work on out around sections on the pipe, and they work on all your AC pipe fittings. So let's go back, look at what we've done in terms of ability to save some money for the utility, cut time, cut cost. Where'd these numbers come from? I've had a couple utilities recently say, hey, let's look at the cost of this versus the cost of our traditional cut and repair. A lot of the numbers that I've got here, we established through working with a couple utilities in Texas. These numbers came from Sacramento out in California. Dave Du Bois out there, the head of the water department, was real interested in looking at this product, and he saw it at the state AWWA at the trade show about 3 years ago. So he bought some, brought them back to the shop, and said, "Hey, let's evaluate this product." So what they came up with were some savings. They reduced the amount of excavation they had to make because they detected the leak. They went down, they saw it was leaking on a joint instead of a section of pipe that needed to be replaced. So instead of increasing the size of the excavation to do a cut-in repair, he kept the excavation smaller. So there was a savings there. That allowed them to cut their labor costs. The intangibles went down. They didn't have to dewater as long. They didn't have to worry about some of those other types of things. What they did was, and I alluded earlier that it's almost a wash on the price of products. They actually elected to restrain across this fitting too. So when they encapsulated, they restrained both ends. And that's a requirement in Sacramento on a lot of the repairs, is no matter what we put in, we restrain across it. And that's not always necessarily needed. But in their case, they had unstable slopes, and so they went ahead and did it. And so if you got movement in your soil or anything like that, you might want to make consideration for that. But so anyways, what they established was that they saved somewhere between 35 and 40% on the cost of the repair through the use of an encapsulation joint. So a really neat way to make some savings and send them back to the ratepayer and to the utility. So when we look at the general product specifications for this product, today we're making them or casting them out of ductile iron up to 12-inch. 16s and 24s will either be fabricated or cast out of ductile iron. The 24s are fabricated. The 16s today are fabricated. We're actually producing patterns to cast those. So it keeps it very competitive if we can cast them out of ductile iron. Gasketing is NBR. And when we look at the gasketing and the material on gasketing, NBR is a great material for gasketing. And the reason it's great is it resists hydrocarbons. It can be used on water, sewer, in the presence of hydrocarbons. You might have a lens of hydrocarbon in the ground that would degrade any other kind of gasket. EPDM should never be used on sewer lines because it degrades in the presence of hydrocarbons. 99% of all sewer lines in North America have got some kind of hydrocarbon in them. So if there's hydrocarbon in the soil from an old leaking gas station, that's going to attack the gasket from the outside. So that NBR gasket, and that's what we're using on all of our gasket material here today, is resistant to hydrocarbons, all your water chemistry, and it's resistant to natural gas, and it meets all of your NSF requirements, 61 or 372 for no lead. We use stainless hardware and everything. All the hardware is coated with the Xylan that I showed earlier, and works very well to prevent galling as you're tightening things down. So what do these sleeves allow you to do? 3 or 4 degrees of deflection. Use them like a coupling, only you don't need a coupling. It splits across it and allows for that to happen across the split. 2 to 225 pounds working pressure, epoxy coated. It's a premium product that's going to save your utility a lot of time, effort, and money in the field. So one of the first things that happened when we developed this product, we came out with a quick sleeve. It was for ductile iron, cast iron. And as soon as we got that in the market, everybody started going, hey, can you do this for AC pipe? Can we do this for some bigger diameter, unconventional type pipe things? So we redeveloped the product. And in the process of redeveloping the product, we do a lot of 3D modeling. But what we had to do was open up the pipeway to accommodate larger diameter pipe. And what the pipeway is the way the pipe goes through the fitting. So if we match these halves together, that diameter that comes the pipe is the pipeway. When we opened that up, the casting got bigger, and this is the best way to describe it. That's the belly of the casting, and the belly got bigger too. And in the process of making the belly bigger, it allowed us to do a lot more with this fitting than you could do before. So you might note on the fittings, there's a port on top and the bottom. The port is for really pressure reduction and bleed down of line content as you're installing it under reduced pressure. They're either 3/4 inch or 1 inch, up to 12 inch. And then on the bigger diameter stuff, they're 2-inch diameter ports. It's a plug port. Everything is equipped with nuts, bolts, and washers, and the stainless steel plugs are already pre-equipped with the product itself in the bolt pack that we supply with that. You plug the bottom, leave the top open for the pressure reduction and blow down. You want to allow the cavity to fill up or the belly to fill up and the air to bleed out of it at the same time. So we did that, and it came out really pretty neat in terms of the way it works and the other things that it does. It will encapsulate AC pipe collars. That was the initial intent. There's a lot more room for universal cast iron pipe. It'll go around all your bells and hubs, old couplings, clamps, flanges, up to the 8-inch size. A full AWWA Class D ANSI class flange can be accommodated by that. It'll cover a lot of MJ pipe fittings. We can give you the internal dimensions. If you calculate the dimension of the fitting you're trying to encapsulate, it'll go over a lot of the stuff that you're looking at with potential for encapsulation. So how do we achieve this? We do that by a layering system in the gasket, and the layering allows us to, as you can see here from this chart, we're not going to spend a lot of time on this chart because the gist of it is the lower range gasket, just like on the coupling with the layered gasket, IPS, ductile, and cast iron. The upper layers are either AC or cast iron and AC. So real simple range system. And the way the layers are set up on these things is there's 2 layers. There's an inner layer and an outer layer on the gasket. And everything is held in place like with a little spoke on a wheel. And that's part of our assembly process. The inner layer is assembled to the outer layer. We use a pressure set adhesive on that. The pressure set adhesive is like super glue for rubber. It's a Henkel or a Loctite product. And what is that pressure set adhesive? Put 2 drops of super glue on it and they don't stick. As soon as you press, it sticks. And that's the way this adhesive works. So we apply the adhesive on the spokes, on the tailing ends of the gasket, and then everything is pressed in place until the gasket and the adhesive set. So the gasket works in a couple of ways. You see the blue layer is your pipe, the green layer is the inner layer, the gray layer, the dark gray layer is the outer layer, and of course the light gray is your casting there. In order to achieve movement, in order for the gasket to set properly, we've allowed for not just the circular space, but we've bumped out and allowed for a little more volume movement on the gasket itself and the casting itself. So this is always a really neat system. We 3D model everything, and as you can see right there, I kind of screwed that up, but let's just go back here to the gasket itself, and what you can see here is blue dot goes to the outside, the groove goes to the inside when we're installing this. The gasket always goes on like this. It's a butt seal. The butt actually butts up on the bottom like that. The butt on that seal is always opposite or at 90 degrees from the split in the case. We don't want to line all these splits up. So we want all of our splits at opposite positions. The gasket itself, if you can see the branding on here, the inner layer on here is 655 to 715. The outer layer is 715 to 765. So 655, 715, 715 to 655. So what that allows you to do is inner layer for ductile, IPS ductile cast, outer layer for your other pipe diameters that are bigger than that. And you know, it's a layer that's reinsertable and could be re-glued. We would rather send you a replacement gasket or have your local distributor actually retain one on the shelf for you in place. It's easier to do that than really try to re-glue and reposition gasketing. So again, gaskets are NVR. High performance gaskets, they're actually rated up to 250. We test everything 375 to 400 psi. If you want to see some of the applications that we've used on these, we had a 6-inch main outside of Providence going into a suburb of Providence called Warwick, Rhode Island. And other side of the river on that 6-inch main, we had a leak under the bridge on the bell joint. There was a health center, couldn't shut it down. So they elected to barge in the repair components. We fabricated a special sleeve for that application, and they installed it in about 45 minutes off the barge, insulated it to prevent it from freezing, kept everything online. Everything stayed in service, no issues there. So neat way to do it. We had a vault out in Scottsdale, Arizona, a 2-inch meter vault. We took the 2-inch down there. It was installed on the leaking fittings on one side of the meter, fixed the problem in about 20 minutes. So these things work on ductile, cast iron, PVC, any kind of push-on joint where you could roll the gasket or over bell. Your old AC pipe fittings, and you can see the old ring joints on each end of those. And there's a lot of that out there. Believe it or not, there's still 660,000 miles of AC pipe in the ground. And the only utility that I'm aware of is East Bay Mud in San Francisco. And they're pretty proactive about removal and replacement of the AC lines out there. And they're doing 19 miles a year. That sounds like a pretty aggressive program. At the rate of replacement in East Bay alone, it's going to take them 50 years to replace their existing line. So the numbers are huge. There's always going to be AC pipe couplings to repair if you've got it in your system, unless you get outright replacement. So, you know, with the bigger belly on the product, it allowed us to encapsulate a lot of things. Ductile iron repair clamp or repair clamps, stainless clamps with ductile iron lugs, fabricated repair clamps, old Hymax couplings that might have failed because of leakage and corrosion problems. Here's your 2-bolt coupling right here being encapsulated down in West Virginia. Very fast, easy way to do it. It went right over the product. The belly is big enough for your AC pipe collars, your universal cast iron pipe, lots of room to move. Old dressers of any kind. Here's the dresser right here, 253, the old Spectrum, like the 441 Smith Blair goes right over that. And if you got flanges up to 8-inch, the 8-inch will accommodate those as well. So we started moving a lot of the 2 through 12s into the marketplace several years back. And next thing we know, we've got a lot of requests for 16s, 24s, 18s, 30s. What we're doing today is on the floor, we're stocking 16s and 24s for emergency repairs. They're a little different. The gasketing is different. Test port is 2-inch instead of 1-inch or 3/4 inch. And they're dedicated to the pipe size because you really can't build the range into it. So we've come up with a different gasket system, and really there's no range adjustment in it. You bring the 2 halves together, bolt them down. We've eliminated the end gland there, and a real fast, easy repair system for your bigger diameter stuff. So on the sizes that we don't stock, like 18, 20, I've got a 30 going through the shop right now. The fabrication time on those is out there about a month. Those would be better for planned repairs, but just keep in mind 16s and 24s for ductile or cast iron, they're on the floor here ready to go. So when you've got these types of sleeves, and we've got to make consideration for how to make the installation on them, like with everything else, measure the pipe once we clean it off. determine the gasket layer, the size of the fitting we're going to use. And then lubrication comes into play on this thing. And it's really important. If you can see, there's an end gland here. We want to make sure that we lubricate the end gland here. And if you look at here, you can see one back here. And, I'll bring this forward little, because it is ductile iron, you can see that the glands, we want to lubricate the glands. Everything comes with a lifting eye as part of the product as it's shipped to you out in the box. But why do we lubricate the glands? We lubricate the gaskets, the side rails, and the pipe. Why do we lube? Because when we're pulling everything down together, everything slides together. We want this split or the casing butt to come together. The casting will actually push down and draw everything together as we tighten everything up. When we go to do the tightening process, there's actually long bolts that go out the outside four corners. Those are your starter bolts. They give you a bigger gap to cinch down with. And then when you're at torque on those, then you tighten these other bolts up that are shorter bolts when you install those during the installation process. So we've thought of a lot of things to really speed it up. Lubrication is essential. I pointed out before back here, we've got that the OD lube, or you can use poly water. There's tons of lubes out there. Rough wall pipe, always use pipe lube, NSF certified pipe lube. On smooth wall pipe, and we're going to use pipe lube always on the glands, on the gasket, on the sidebars, and on the pipe for rough wall pipe. On smooth wall pipe like PVC, HDPE, anything like that, maybe even copper pipe, you're going to want to use just soapy water on the pipe itself. But otherwise, we're going to use pipe lube on those glands. If we use pipe lube on the smooth wall pipe, that allows for almost a permanent lubricity on the pipe and allows that gives you the potential for the product to move and slide on the pipe. You really want to eliminate that, and the best way to do that is to only lubricate with soapy water. So lubricate with the proper lube per the directions, and again, that's why we want to make sure that we read the directions. What do we torque these things down to? Most of the product labeling says 100 foot-pounds. 100 foot-pounds brings that right down, gives you a leak tight seal between 2 and 250. And again, it'll test to 375 to 400. So everything's on the product labeling. This is what the side bars look like when they're tightened down at 100 foot-pounds. You're almost metal bound, metal to metal. This depicts and shows you really what the gasket looks like. That's at right angles to the split in the case. And, on any of these sizes, you've got a repair that can be done in 30 minutes or less. With an encapsulation like that. So a lot of the courses I get in California in particular, they say, hey, send your survey out, and we've got to have a way to verify that these guys were online listening to the end. So at the end, we use a code phrase. It's called Ultra Sleep. So as soon as I get the survey back out there, I got that Ultra Sleep on the survey. I know they've been there to the end because I heard the code word. So we're not using that today because AWWA is taking care of that, New York State AWWA. And so we do stuff to some pretty big diameters, repair clamps, 48 inches long, 54 inches in diameter. We make corporation abandonment fittings. There are a lot of different kind of specialty fabrications that we're producing here in Olean, New York. So, on that note, think Ultra Sleeve as an alternate way for making your repair. And, it could be something that could save you time, could save you a lot of money. So on that note, I want to thank everybody for sitting in to this short talk this morning. And if anybody's got questions, give us a call at our number in Olean, New York, just Total Piping Solutions, or you might have seen our logo on some other products, TPS. And, again, I want to thank everybody for sitting in. And if you need information, give us a call. Thanks.